Welcome everyone, and so today we're going to continue looking at the normal distribution. Those facts that we saw in the last video are still going to play a part in this video here, and we're going to continue using the normal CDF function. And so as a reminder, Hawks Learning is going to show you how to use a table to find these answers. We're using the calculator and the function normal CDF to find these answers here. And so just keep that in mind. We're using the calculator. Hawks Learning is going to show you a table. And so these problems are going to be very similar to what we saw. The difference is they're random values and not z-score values. And so let's look at this example here. Suppose IQ scores follow the normal curve with the mean 100 and standard deviation of 15. Let's use this information for parts A, B, and C. And so if you want to, you could take a minute, pause the video, write down this information, and let's see if we can find the probability for A, B, and C. And so one thing to keep in mind as we're looking at these examples, here these examples are going to say what is the probability or find the probability. Find the probability is the same thing as finding area. Find the probability tells you to use the normal CDF function. And so when we look at these problems and you're wondering, when do I use normal CDF? Whereas when you're finding the area or you're finding the probability. When you're asked to find area or probability, that tells you to use the normal CDF function. You're going to set up your lower and your upper bound very similar to what we did in the last video, where you're looking at either the left or to the right or in between two values. And so let's look at A. Find the probability that an individual has an IQ below 88. And so again, find the probability tells us we're using our normal CDF function. We're looking for everything below 88. And so our setup is going to look like this. We're looking at 88 on our curve, everything below, everything to the left of 88. And so because we're looking to the left of 88, we're going to have negative E99 as our lower bound, 88 as our upper bound. The mean is 100, the standard deviation as 15. And so if you want, you can pause the video, see if you can put this into your calculator, and see if you can find that probability. And so if you put that into your calculator, you should come around 0.2119. And so there's the probability that an individual has an IQ below 88. Let's look at B. Find the probability that an individual has an IQ above 120. And so here we have 120 on our curve. We're looking at everything above, everything to the right of 120. And so you just want to remember when we're looking to the right of a value, that value is going to be your lower bound, in this case 120. Because we're looking to the right, our upper bound will be E99, the mean as 100, the standard deviation is 15. And so again, see if you can put that into your calculator and see if you can find that answer there. And if you do, that should come around 0.0912. And so the probability that an individual has an IQ above 120 is around 0.0912. And then lastly, let's look at C. Find the probability that an individual has an IQ between 55 and 145. And so here on our curve, we have 55, we have 145. You're looking at everything in between those two values there. And so that's going to leave us with our normal CDF since we're looking for probability. 55 as our lower bound, 145 as our upper bound, 100 as the mean, 15 as our standard deviation. And that should come around as 0.9973. And so let's take another example. And so we just want to make sure we have a good handle on the normal CDF function before we move on to the next lesson. And so let's look at just a couple more examples just to make sure we have a understanding using the normal CDF function. And so let's look at this example. The weights of steers in a herd are normal disputed. The variance is 90,000 and the mean is 1,300 pounds. What is the probability that the weight of a random selected steer is between 850 and 1,656 pounds? And so again, wording is key when we look at these problems. Not only that, but the facts that we saw in the first video with the normal curve is key. You want to remember when it comes to the normal distribution, it's completely defined by two values, the mean and the standard deviation. The mean and standard deviation make up, it defines the normal curve. That's why we use those two values in the normal CDF function. And so in order to use that function, you must have the mean and standard deviation. If you don't have those two values, you then have to find them. And so if we look at this problem here, we are given the mean, but we do not have the standard deviation. We have the variance. And so what's going to happen is we're going to have to find our standard deviation in order to use our normal CDF function. And so you want to remember from our chapter when we were looking at measures of spread, we took the square root of the variance to get to the standard deviation. You're going to do the same thing here, where you can take the square root of our variance, and that gives us the standard deviation, and then we can use the normal CDF function. And so we're looking for probability. That tells us normal CDF. We're looking at in between 850 and 1,656 pounds. And so when we set this up in our normal CDF function, we're going to have normal CDF. 850 is our lower bound, 1,656 as our upper bound. The mean was 1,300. And then we're going to have the square root of 90,000, the square root of our variance, to give us our standard deviation. And we can do that square root right inside of the normal CDF function. And I highly recommend you do the square root of the variance within the normal CDF function. When we get into the next chapter, you're going to have to be able to do this type of square root inside of the normal CDF function, and so this is good practice. And so see if you can get that into your normal CDF function and see if you can get the answer that you see here, 0.8155. And so you may want to make yourself a note just for the reminder. You're going to have problems like this where you're given variance. You just want to remind yourself to square root the variance to get to the standard deviation. Let's take a look at two more problems. Let's say the life of light bulbs is normal. Let's say the variance of the lifetime is 225 and the mean lifetime is 590 hours. Let's find the probability of a bulb lasting for at most 624 hours. And so that's for A. For B, let's say the life of light bulbs follow the normal curve. The standard deviation is 15 hours and the mean is 550 hours. Find the probability of a bulb lasting for at least 577 hours. And so pause the video, take yourself a minute or two, and see if you can set up both A and B. And so as you're looking at A, you're given the mean and the variance. And so you want to keep that in mind, that in A you're given the variance. And so therefore you're going to have to square root the 225. And so here on A we want to find the probability for at most 624. And so you want at most 624, nothing beyond 624. You're just going up to 624. And so as you're looking at A, you want to set up your normal CDF for everything to the left of 624. Then for B, you're looking for the probability for at least 577. And so here you're looking at least 577 or more than 577. And so when you're setting up B, you want to set up for everything to the right of 577. And so for A, this should be our setup, normal CDF. Negative E99 as our lower bound, 624 as our upper bound, 590 as the mean, and then the square root of the variance, 225. And that should come around as 0.9883. Then for B, our setup should look like this. We have our lower bound as 577, our upper bound E99, our mean as 550, and then the standard deviation was 15. And that should come around as 0.0359. And so let's take a look at one last problem. Let's say a soft drink machine outputs a mean of 23 ounces per cup. Let's say the machine's output follows the normal curve with a standard deviation of 4 ounces. What is the probability of overfilling a 26-ounce cup? And so go ahead and pause the video and see if you can set this up for your normal CDF function and see if you can find that probability. And so here we're looking for the probability of overfilling a 26-ounce cup. And so our setup should look like this. We're looking for overfilling, and so everything to the right of 26. And so our lower bound is going to be 26, our upper bound E99, the mean 23, the standard deviation as 4. And that should come around as 0.2266. And so this ends this video here, looking at the normal CDF function to find a probability. And so if you have any questions or concerns, just let me know. The next video is going to look at the last material for this chapter and using a different function for the calculator.